Good evening. This is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. Today I am going to deliver a topic, speed control of DC motor from the subject, Basics of Electrical Engineering and Instrumentation. So DC motor is one which converts a electrical energy into mechanical energy. So the speed of the DC motor can be controlled by varying either the flux or can be a rheostatic control. So the flux or field control and rheostatic control or magnetic resistance control are the two types of speed control of DC motor. So first we can see what is the speed control of the shunt motor. So under the speed control of shunt motor, first one is a flux or field control. So the flux can be controlled by adding the rheostat in series with the shunt field winding. At the beginning, the rheostat is kept at minimum and R is increased. The rheostat increased due to which later the R is get increased due to which shunt field current ISH will be decreases, which in turn decreases the flux produced. Advantage here is it is relatively smooth and easy. The speed control above the rated speed is possible. Field winding resistance is high. Field current is small. Power loss is very small. Field current is small, so the size of the rheostat is also very small. The drawback is that the speed control below the normal rated speed is not possible. And second is a armature or rheostat control method. So in armature or rheostat control method, the supply voltage is constant. The voltage across the armature can be controlled by adding the resistance in series with the armature. In previous one, it is the rheostat is added along the field winding. Here it is across the armature. So the field winding is excited by the normal voltage. Initially the rheostat is minimum. For a given load, armature current is fixed. Voltage across the armature decreases, decreasing the speed below the normal value. By varying the extra resistance various, speed below rated value can be obtained. Advantage is that easy and smooth speed control. Drawback, entire armature current passes through the external resistance, so there is a power loss. Speed above the rated is not possible. Due to large power loss, the method is inexpensive. So this method is expensive. Need expensive heat dissipation arrangements because the heat that is produced is large. And next is a speed control of DC series motor. So the flux that is produced by the winding depends on the magnetomotive force MMF. So MMF is a magnetomotive force. It is a product of current and number of turns of a winding through which the current is passing. Flux can be changed by adding the resistance or by adding the number of turns of the winding. First one is a field diverted method. Series field winding is shunted by the variable resistance Rx. By adjusting the Rx, any amount of current can be diverted to the diverter. So due to this, flux get controlled and speed is get controlled. So field winding increases the flux and motor speed is get reduced. So this is the field diverted method connection diagram, and the next is the speed current characteristics that is produced because of this. And next is the armature diverted method. It is used for motor which requires a constant torque. Armature of motor is shunted with the external variable resistor R. So R is called as a armature diverter. So any amount of diverted current is diverted through this diverter. Due to this IA, the armature current is get reduced. Current through field winding is increases, flux increases, and the motor speed is get reduced in this armature diverted method. And next is a rheostat control. So under this rheostat control, Rx is inserted in series with the motor circuit. So Rx is connected in series across the motor. So, and we have this field winding and we have this supply. As our resistance is inserted, So there is a voltage drop across the resistance occurs. So resistance is connected in series with the motor and there is a voltage drop occurs across the resistance. So this reduces the voltage across the armature. So the voltage drop across the resistance reduces the voltage across the armature. So as we all know that speed of the motor is directly proportional to the voltage available across the armature. Since there is a voltage drop across the resistance, because of this the resistance is connected in series with the motor, and because of this voltage drop across the resistance it is connected in series with the motor. So the voltage across the armature is get reduced. Voltage across the armature is directly proportional to the speed of the motor. Since the voltage is get reduced, the speed is also get reduced. So the speed of the motor here is get controlled by adding a resistance in series with the motor. So because of this resistance, the voltage across the armature is get reduced. So voltage is directly proportional to the speed of the motor. So because of that, the speed of the motor is also get reduced. So that's all about the speed control of DC motor. Thank you.